All right, so we're going to do a couple of each of the topics of benchmark today. I'm going to say this. I'm not just going to answer these questions. I'm going to make notes that I know are going to help you on all of the questions. Okay, before I do anything, and we start with number 1, take a second right now and flip to number 19 for me. Okay, we're going to work on this packet kind of out of order and all over the place, but I want you to make a note of this, okay, before we get ahead of ourselves in benchmark, okay? There are 2 topics on benchmark, 2 questions that Ms. Bluen and I are not counting because we haven't taught it yet. This is one of them. So this is about the Pythagorean theorem, okay? And then we have another question about volume, all right? So this is not, when I do at some point at the end of the class tomorrow, when you start working on benchmark on your own, you need to know that Pythagorean theorem and volume are not counted on benchmark, okay? So you're welcome to try this problem on your own. Honestly, no reason to do that to yourself, okay? After you have this, everyone is going to number 1, and we are going to label those parts of the equation, okay? All right, Pythagorean theorem and volume are not counted on benchmark. This is a Pythagorean theorem question. We are not counting them because we're going to teach them the week after benchmark, okay? All right. Number 1, you have to be able to know the parts of this equation and follow all your directions. This didn't just say to label, it said to label and explain. So we need to understand that M is our slope, B is y-intercept, and X and Y is an ordered pair. That makes it true. Okay, so I have them labeled. I'm going to take a couple of extra words to explain. Okay, so slope is, of course, a rise and run, where rise moves up and down and run goes to the right. We also know that as a constant rate. Okay. Y-intercept is where the line cuts through the y-axis. And a lot of times we tend to forget that X and Y go together as an ordered pair. Okay, they are an ordered pair that make this equation true. So whatever you plug in for X and you multiply by your slope and add to your y-intercept, if whatever the numbers may be, let's say you get a value of 10, well then that would mean that your y would have to be 10 because it is a balanced scale. So an X and Y ordered pair, that makes it true, that makes it balanced, okay? All right, like I said a minute ago, I'm going to go do one of each topic, okay? I'm going to go through and do one of each topic. We're going to label it that topic so that when you go back and you do your focus area, you know which ones are which topic, okay? Since we just did one with slope, let's go ahead and write slope by number 1. And let's go ahead and stay on that topic. We're going to do another slope problem, which is number 3. So please label slope as number 3. And then let's go ahead and solve this one together, okay? Now, this is a y equals equation that we are asked to fill in a table and then put on a graph, okay? Did I give you X values to plug into this equation, or do you have to come up with them on your own? I gave them to you, okay? So if I were you, I would be going set up my template that I know I'm going to do each time so that I'm simply plugging in X's, writing ordered pairs, and then graphing them, okay? So that should look like this. Y equals, plug in my slope, -2. I'm going to put parentheses for X because I'm not writing X. I have numbers to put in for X, plus 9. And then I'm going to set this up each time. Y equals -2, open parentheses, plus 9. Y equals -2, open parentheses, plus 9. Y equals -2, open parentheses, plus 9. Okay? And as I go to start plugging in, we're going to make a little side note here that is something great to study for benchmark. What's the first value that you plug in for X? 0. What do we know? What important note did we take about where X is 0? It's always what? It is always your Y intercept. So that is something that I would want to make a note of. So go right there to the side. This is a perfect note to study with. Wherever you see X being 0, that is your Y intercept. Okay, so wherever X is 0, the Y value is your Y intercept. Okay, that being the Y value. Okay. And now I'm going to keep going, plug in my X value. So -2 times 0 is 0, and 0 plus 9 is 9. So I'm going to write that as an ordered pair, 0, 9. And then I'm going to go graph it. So no movement left or right. And then up 9. Since this is a linear equation, what do you know is going to happen or should happen when I keep graphing these points? It should make a straight line because it has a constant rate, right? Same thing like a linear function. So let's keep going. Let's plug in 1 together. -2 times 1 plus 9. I strongly suggest that everyone, Miss Bluen students, my students, you should be using a calculator, okay? So -2 times 1 plus 9 is 7, okay? And then we have an ordered pair of where X is 1 and Y is 7. So remind yourself when you go to graph, another great note you can take right here. When we are graphing our X's, X values graph left or right. Y values graph up or down. Thank you. So this means 1 to the right and 7 up. All right, let's do it again. Let's plug in 2. -2 times 2 is -4. And -4 plus 9 is 5. So then I have the ordered pair, 2, 5, which means 2 to the right and 5 up. And lastly, it asked me to plug in 4. So -2 times 4 is -8. And -8 plus 9 is 1. So I have the ordered pair 4, 1, which is 4 to the right and up 1. I'll connect my points, which clearly make a straight line. And that is everything we should have for this. We noted that wherever X is 0, that Y value is always our Y intercept, which proved true on our graph. And we made the graphing note when we're graphing, just as a reminder, you start at the origin. X tells you to move left or right, and Y tells you to move up or down, okay? So we did 2 problems on this that are on the topic of slope, okay? Next, I would like to do the topic of systems. So we are going to jump to number 9. So please make sure everyone is looking at number 9. If you've already done number 9, then you're watching and taking the extra notes that I'm adding to this, okay? I would consider number 9 one of your most common topics on this test, okay? So we're going to go through each of these types of solutions. So what does it look like when a system has one solution? The 2 lines do what? Cross. Very good. They intersect. So we know that in one solution, those 2 lines will intersect, okay? They will have different slopes and different y-intercepts. Oops, sorry about that. Okay, so they will cross at that one spot of x and y. They will have a different slope and a different y-intercept, but they will run into each other at some point. You cannot determine that unless these equations are in y equal form. So I can give you all of these notes on this, but if you try to look at this right now and tell me what the answer is, I can't even do that because I don't know what the slope and the y-intercept of these equations are. So I think the most important note to take on all of this, even before we keep going through this, is writing right here that you must convert these to y equals mx plus b form. You have no way of knowing if the slopes are the same and the y-intercepts are the same if you don't know the slopes or the y-intercepts. And you don't in this form. You don't know what they are. Okay? So I'm going to do that with you in a second. We're going to convert them and determine. But once we convert them and determine, oh, okay, this one has a slope of 2 and a y-intercept of 4 and whatever it is, and we can compare them, then we can answer this stuff. Okay? So we talked about one solution. And if we have different slopes and different y-intercepts, they will run into each other, right? What about no solution? The whole point of a system is to find where they run into each other. So what if they don't run into each other? What will they look like? Yes, they will look like, what is this called? What are these called? Parallel lines. Yes, they will look like parallel lines. Okay? Parallel lines mean they started at different points, but they're moving the same way. So that is having different y-intercepts, but the same slope. Okay? Different y-intercepts and the same slope. Like I said, that's at starting different points of a race, but you're running the exact same speed. You're never going to run into each other. And lastly, infinitely many solutions. It's what? It looks like one big line. Why? They're the same. Exactly. Very good. Because they are the same. So they have the same slope and same y-intercept. So they're the same line. So it's going to look like a bolded line because they're on top of each other, right? They're graphed on top of each other. So I'm going to go back to what I wrote at the top up there. I can't answer any of that until I actually know what the slope and y-intercept are of these lines. So now that we kind of have these notes, let's go convert these lines, convert those equations, and then we can actually determine the answer. All right? To do that, I'm going to write each of those equations to the side and convert them. Okay? Y'all and people watching the video, you write it right here. Okay? For the sake of you practicing converting, I'm going to write it right here so that everyone can see big and clear. Okay? But you just fit it in the spots right there. I'm going to take this first equation right here. 6x plus 3y equals 12. To convert that to y-intercept, I need to get the x to the other side and then simplify it. So I'm going to do minus 6x and minus 6x. And I'll be left with 3y equals negative 6x plus 12. What's next? Good. Divide by 3, and divide by 3. You should be writing this. Thank you. Y equals negative 6 divided by 3 is negative 2x. And 12 divided by 3 is positive 4. Okay? I said a second ago that you need to just write it on the sides. I'm writing it right here for the sake of the video. So I converted this equation right here to y equals negative 2x plus 4. So I now know that this has a slope of negative 2 and a y-intercept of 4. So when I go convert the other one, I actually have something to compare it with. So I'm going to go do the other equation now. 6x plus 3y equals 24. Again, I'm going to bring 6x over to the other side as a negative. 3y equals negative 6x plus 24. Divide by 3, divide by 3, divide by 3. Y equals negative 6 divided by 3 is negative 2x. I'm going to pause right here. The slopes are the same. So what option have you ruled out of this being? One solution. For them to actually have an answer in a system, everything has to be different. Different slopes, different y-intercepts. These have the same slope. So if I've ruled out an answer choice. It's either going to be no solution where they never run into each other, or one solution where they're the exact same line. Huh? I'm sorry, infinite, yes. I mean, no solution where they never run into each other, are infinite solutions where they're the exact same line. Thank you. Okay, good. Why, Gavin? 24 divided by 3 is 8. So y equals negative 2x plus 8. So when I go and say, well, this equation right here and this equation right here, they have the same slope, but they're starting at different points. So one's going to start at 8 and one's going to start at 4, and they're going to move the same way, and they're never going to run into each other. So this system has no solution. No solution. Okay? There are many questions on this test where you will need to convert. So if you need to just go back and ever rewatch converting from standard form to slope-intercept form, that's 2 examples, okay? I will tell you that you only actually have to solve one system on Benchmark, but you will have 3 questions about determining how many solutions. So that is something super important that you may need to watch again, okay? We are going to quickly do 2 more, okay? I would like you right now to go to problem number 2 in this packet, which is about functions, okay? So we are going to flip back to number 2. Bear with me. And this one will not take long. This is looking at which of the following equations are non-linear. Well, I gave you, and we talked about 2 very specific rules when we're looking at an equation that will make something non-linear. Okay? One of them was what? Please tell me what was one of them, Reagan.
It cannot have a exponent
On a variable. That is very specific. This one right here has an exponent on a variable. Do you know what x to the power of 5 is?
No.
I don't. I have no idea. So it could be 0. It could be a fraction. We don't know what it could be, but I know it's not going to make a straight line. So what I'm going to write is that this is nonlinear. And the rule is because a variable cannot have an exponent. Right? Okay. You have all this written? I know. All right. I'm going to work my way to the left right here. This is y equaling x divided by 9. X can be a numerator. There's no exponents. This is perfectly linear. This, I don't know what the slope and y-intercept are, but I know I can convert it, and I know it wouldn't have an exponent, so this is perfectly linear. This is tricky because you see an exponent, but I'm going to ask you one question. Do you know what 5 times 5 is? Yeah. So you could work this out and say, well, this would be 25, which is y equals 4x plus 25. That's perfectly linear. So this would be linear. But this last one has a problem because x is the denominator. And x cannot be a denominator because what if I work this out and x were 0? And I got something like y equals 9 divided by 0. What happens when you do that in your calculator? It doesn't work. You get undefined. So this one is also nonlinear, x cannot be a denominator. Okay, because it could potentially be 0. Okay, I'll get that focused and make sure you have all the parts. So our two answers there for nonlinear were the first one and the last one, and I wrote the rule underneath both of them. Okay. Okay. Last one, and I think this is probably the relatively easiest one, is going to be number 16. Okay. So if you're still copying this, we'll come back to in a second. If you're on the video, you can pause. Everyone else, we are going to go to number 16 real quick. Okay. And we should have written that number 3, number 2 was a functions topic. Okay. And number 16, this is the topic of comparing rates. And this is a constructed response on benchmark. So you might want to add that too. All right. So I'm going to just kind of set this one up and let you go from there. So this one, I don't think is difficult. I think a lot of you are going to not answer it correctly. This is telling you that the store Sam's is selling melons at this rate. I think it's confusing because they don't use Y and X. You need to understand that T equals 3P would simply be like Y equals 3X. So they are straight up telling you, hey, the store Sam's is selling for $3 per 1 pound of melons. Here's what they're asking. And you have to not only be able to find the cost, but you have to understand what a better buy is. What is a better deal? If I'm looking for something with a better deal, do I want to pay more money or less money? Less money, okay? So I need to look at all of these different stores and see which one is going to be less money per 1 pound. None of them give them to me per 1 pound though, right? So I need to go to each store and say, well, if Costco is selling $10 for 3 pounds, then I can divide that and see what the rate per 1 pound would be. And I'm going to keep checking to see which one is going to have the best deal compared to Sam's. Does that make sense? So you tell me, what is $10 split by 3 pounds? How much money per 1 pound would that be? So $10 split by 3 pounds is $3.33 per 1 pound. Is that a better deal than Sam's? No, that's more. It's 33 cents more. Very good, per 1 pound. So that is not a better deal. Okay, so you need to keep doing the next two and tell me which one is a better deal. Okay, so let's do the next one together. Safeway has $11 for 4 pounds. Tell me, what is the cost per 1 pound? $2.75. Is that a better deal? Yeah, so far that is the best deal. I need to check the last one. Okay, but so far Safeway has the best deal. Okay, let's check Whole Foods. Whole Foods, it's $16 for 5 pounds. And what is the cost per 1 pound? Is that a better deal, $3.20? No, that's more money. So if you had to explain in a sentence, I'm going to pause here. You're going to write the final sentence. What would you explain is the best deal and why, if this were a 2-point question? Safeway is the best deal. Why? It has the cheapest constant rate, the cheapest cost per pound compared to Sam's, or really compared to all of them, right? $2.75 is the cheapest cost out of all of them. Okay. All right. That was one of each topic. Please email me if you have any